So, Vanakkam, we will continue our lecture on engineering seismology. So, we are recapping basically what we have taught in the so far in the several classes, so that the people who even see these videos okay, for the next couple of hours can able to understand the whole subject. Okay. So, only here I am highlighting only the very important part. So, if you have to go through the detail, you can go to the each lectures. So, here in the half an hour we try to cover 3-4 lectures together and give the highlight of the what we are discussed so far and how it is important for the your next classes. Okay, that is what we are doing. So, last class we discussed about the earthquake mechanism, plate tectonic, and then the earthquake was occurring, continental drift theory, all those things. So, today class, so when they started understood that the earthquakes are happening due to the the plate tectonic kind of things, then people try to understand the earthquake source, okay, and then classify the earthquake depends upon the where it occurs, and classify the earthquake where it occurs, the source mechanism, okay, they are the fault kind of things. So, as I told you that the earthquakes breaks and releases the energy. So, generally these breaks are frequently happening where there is a weak zone. That weak zone is called as a fracture, okay, fracture or crack. So, in the geological form, as I said that the each plate is a rock. So, there is a fracture in the rock, okay, cracks in the rock, that particular place is called as a fault or it is a fracture. You can see the fracture or crack. So, where two sides move past each other and the relative movement of the parallel to the fracture. So, this is how you can visualize the source. So, basically the fracture is the joints, okay, or a weak zone. You can see here this is the fracture, okay. So, this is the fault. So, sometime this fault come up to the surface and causes a surface evidence. So, that is what you have seen in the San Francisco. There is a two fault visible, there is a crack, physical cracks are visible. Sometime this may not be appearing in the surface due to the formation of the soil and weathering, and sometime it may not even reach. Those kind of fault are called as the blind fault. Okay. So, the fault consists of the both side. I said the weak zone, it has a two side. So, one side is called as a hanging wall, the other side called as a footwall. Okay. So, that means the fractured zone, two side you will have, one side will be the hanging wall, another side is the. So, the plane, okay, the line, fault line is called as a fault plane. So, the fault plane makes angle with the horizontal plane is called as a dip, you can see. So, this is the dip. Okay. If there is a fault is vertical, perfectly vertical, you should have 90-degree dip. Okay. The fault plane makes angle with the north direction is called as a strike. Okay. So, this is the strike. So, the fault plane makes angle with the north direction is called as a strike. If the fault is oriented towards north direction, you will have the 0-degree strike. So, that is what written here. So, these are all the way you can define your fault dimensions. So, we have been discussing the dip and then the strike. So, when we are simulation of earthquake, we told, no, I told, so you need a dip angle, strike angle for a give as a input. So, that dip and strikes are defined in the very long back on the class called seismic sources. So, depends upon the how the hanging wall and footwall moves each other, what kind of force involved, the fault can be categorized here different types. Okay, this is called as a type of fault. Okay, so, this can be broadly into 3 group and then you can make it to 3 into 3, 9 category. So, how the broadly 3 group? So, let us see how we are making. One is the normal fault. So, normal fault means basically the hanging wall moves down. Okay, the hanging wall moves down. You can see here the hanging wall moves down. The force involved is actually tensile force. So, this kind of fault is called as a normal fault. So, now you can see that the divergent boundary belongs to the normal fault. Okay. The second is reverse fault. So, where the hanging wall moves up, okay, the compressive force is involved. So, this is a convergent kind of fault. plane. Convergent boundaries are comes on the river. Another one is the strike slip fault. Okay, so where the fault moves each other doesn't cause any vertical displacement. So these two are causing a vertical displacement. So this is only causes a shear. So this is a strike slip fault which is occurring in the predominantly on the transformed boundary. So now you can see that there is a downward movement, okay, and then there is also a shear movement. Then this become a normal strike slip fault. Here the upward movement and as well as the shear, this is a reverse strike slip fault. Okay. So like this you will have the combination. If it has your rotation, not only movement, it moves vertically, horizontally and causes a unequal rotation, because it is a earth phenomena. You cannot define very perfectly like this should happen, like it should happen like this, like this, like this, not. Okay. Earth it can happen its own way in the nature. So that is why sometimes you have vertical displacement, horizontal displacement and also rotation, the thrust fault. So that kind of fault is called as a normal strike slip thrust fault. Okay. So reverse strike slip thrust fault. So reverse thrust fault or normal thrust fault or strike slip thrust fault. So something like that which involves a displacement, rotation, horizontal and vertical displacements. So this is how the three major category of the fault can be defined, and 3 into 3 9 category you can produce out of this. Depends upon the location, this can expected to occur at a particular place. So this is about the different type of fault. So we also discussed about the blind fault. The blind fault means the fault it never approaches to the ground, okay, but still it causes a earthquake, it has a fault plane and it is also contribute to the seismic activity. For example, this is the earthquake, you can see the fault plane. So even it ruptures, it goes because there is another fault. So this rupture will hit and stop here only, it does not proceed further or does not go to the ground. So this kind of fault is called as a hidden fault or blind fault. So these things are only comes to notice soon after the big earthquake in that area. After recording the data, one can find out what kind of source mechanism, what depth, okay, what dimension fracture, then they can map this kind of fault. Okay. So now you may be understand that why I do recapping. So if you see that many things what we studied later stage of the class, these are all the class we discussed previously, but after understanding the simulation and then the earthquake measurement, all those things, now we visualize this definitions and discussion of these things very well. So that is what I am doing the recapping actually, because it is the knowledge of the subject. So you will understand more and more if you read and then repeat the same thing again. So that is why the blind fault and all can be understand if you have the earthquake record. So the fault can be categorized. Okay. So the whatever we discussed earlier, hidden fault, blind fault, surface fault kind of things, which is based on the orientation and location. Another is the active and inactive fault. This is the two major category which is very responsible or very important. Okay. So for the hazard analysis and prediction of the earthquake hazard, future earthquake hazard. So if you have to predict future earthquake hazard at particular location, you should need to know what are the faults are active, what are the faults are inactive. Why? Because as I told that the fault is a fracture and a weak zone. This fracture weak zone might have been caused by the several million years. As we have seen that these fractures are keep changing its position, location, everything with respect to the geological age. So the activity is a very important to assess for the future hazard at a particular location. So the inactive fault, the geologist or seismologist given some kind of guideline to define inactive fault. So the last displacement to occur at along a typical fault may have taken place before 10,000 years or before 2 million years. So those kind of location or fault can be defined as a inactive fault. So this what you can do, you can take a samples from the particular place, carbon date it, okay, different material available in the carbon date. All the material in the particular weak zone shows that it is very old. That means there is no activity has been happened in the recent. Okay. So those kind of plane or fault you can define as a inactive fault. You can ignore those things for the seismic hazard analysis. Okay. The next is the local disruptive forces on the earth near may have subsided long ago. So there is no movement of the plate in that area, there is no land mass movement. So how do you know the plate movement? I hope I have told you this. So there is a global positioning system, very high precise global positioning system, which has been anchored in the crystal rock. Crystal rock means the crust projected to the ground, okay, that ground they anchor it. So these are all the places in all the continent it is available. So in particularly if you look at the India where the crust rock formation you can find, Bangalore the crust rock you can see is the Lal Bagh. So whenever you go to next time Lal Bagh, you can see the Lal Bagh rock, no, that rock is actually the crust rock. Okay. So that movement of that rock actually implies that a plate movement below the several kilometer, because that rocks comes and projected in that place. Not only there, within IISc also we have the crust rock. If you had a chance to go to IISc, so there is a main guest house. After the main guest house there is a swimming pool. In between there is a outcrop. That outcrop basically is a crust. So the crust formation come to the surface, due to the weathering it become a hard granitic rock. That kind of rock people will identify and position a high precision global positioning system. Then if you monitor that system with reference to some point, then you can know that it is moving or not. If there is no such kind of movements is taking place in that plate, that is called as a basically subsided long ago, there is no movement, that is basically inactive plate or inactive fault or inactive source. Those kind of weak joints are the inactive source. Okay. And apart from that, you can also taking a water, okay, the chemical process involving water movement may have cemented rupture, particularly shallow. So sometime what happened due to this weathering and all, even there is a fracture. So this slow down or subside, okay, the movement of the fault, okay, will the water act with the materials in the rock or soil, it become the chemically composite due to the weathering process, and this chemical may be filled this kind of weak zones and which become a solidified. Okay, that kind of things also is a evidence for the inactiveness in the particular area. So this is how you can take inactive fault. So then how do you define an active fault? So active fault you can define the crust displacement can expected to occur. So the crust displacement means there is a movement in the GPS, high precision GPS position showing that the crust is moving. So that kind of place you can take it as a active fault. Second, many of these faults are rather well defined tectonically active regions of the earth as a mid oceanic ridge and along the mountain range. So you can see that we are telling that the Himalaya is growing every year so many centimeter, okay, 2 centimeter, 4 centimeter, whatever the number. So which indicates that how it grows, there is a movement occurring in the plates. Okay, that indicates that these regions are active and the source in that region like fault in that regions are active fault. Okay. Similarly, the oceanic ridge where the volcanoes are occurring, which indicates that there is a movement is occurring on the plate. So however, the sudden fault displacement can also occur away from the region, clearly present a tectonic activity. So even if you place a seismic instrument for some period of time, there is a minor earthquakes occurring in those regions will indicate that there is a seismic activity. Okay. Or you can take a carbon dating of the material and also define period or movement occurs in that region using the carbon dating, that kind of things also will be useful. So people try to understand its activity and fault movement by doing a very detailed studies. Okay. Those kind of studies are called as a monitoring instrumentation deployment of the seismic source. So this is actually a San Francisco where San Andreas fault. So people drilled borehole up to 2-3 kilometer and instrumented that and tried to monitor how the stresses in the sensors are recorded, how the displacements are recording, so that you can able to predict a earthquake accurately. So this kind of research, but this needs lot of enormous funding. Okay, I don't know the country like us, we are afford to do this kind of drilling and all, but still this kind of project also taken up in India. Recently Koina they try to understand the seismic source by drilling a hole and say putting the sensor, collecting the core, okay, in the Koina earthquake region. Okay, so this is the similar kind of study what they have also done in the San Francisco. This shows like the drilling and then occurring of the different earthquake and then the sensors are monitoring and then try to see that how accurately we can forecast a earthquake based on this data. But as on now, it is not very success, even though they spend several crores of rupees, like 500 crore, 1000 crore or 5000 crore, I don't know exactly what amount they have spent, but those amount, after pumping so much amount also, there is nothing like they could able to say that because we measured this many data, the earthquake going to come this time, nothing like that. There is no scientific development happen on earthquake prediction. Okay. So only they have studied what happens. This is a typical study. So where you can see they drilled a hole and then fixed a lot of sensor and try to monitor the stress strain induced in this region due to and the earthquakes and the recordings, all those things are taking into places. So this is what about the seismic source and the classification and activity, like inactive and activity. So the another one is, so as we even though call it as a earthquake, so as you are seeing that the earthquake occurring at different places will have different form of seismic wave and different strength of energy release, different way of the wave propagation is happening. So the understanding of earthquake, okay, the vibration, okay, so is a very important. So generally the earthquake is called as a vibration created in the earth. Okay, so depends upon the vibration, the source, the earthquake can be defined as a different type. Depends upon the where it occurs, it can be defined in different. It depends upon the what depth it occurs, it can be classified. So the types of earthquake, causes of earthquake, okay, so you can see. So the energy may be originate to cause a vibration from different sources. So based on the source, we can say that the dislocation of the crust, which is a tectonic, volcanic eruption due to the volcanic activity, man-made explosion, so where you can do some bombing and blasting, and then collapse of underground cavity, mines and crust. So these are all the way the energy originates from the different part of the earth. Okay, the source of energy will give you the type of earthquake. So the tectonic earthquake, basically these are all the earthquake which occurs due to the earth crust breakup. Okay, movement of the earth crust and breakup, and geological force is created by the movement and tectonic plate. These are called as a tectonic earthquake. More than 95% of the vibration happening in the earth is due to the tectonic activity. So the volcanic occurs conjunction with the volcanic activity at a particular place. So this vibration is also recorded. This is a volcanic earthquake. Collapsible earthquake occurs due to the excavation of mines and then caverns, where these mines and caverns, okay, so try to equalize the force. So okay, so it causes some kind of vibration, that is a collapse earthquake. These collapse earthquakes are generally expected above the mining area. For example, people who are aware South India, there is a KGF. Okay, so after movie of KGF, many people may be knowing what is the KGF. So the KGF is actually Kolar gold field. Okay, so in that region, what they found a gold metal in the earth. So then they did a mining to extract a gold. So when they did a mining, basically they cut gold and the non-gold material together and bring it to the surface, and then they do some kind of chemical processing, try to separate a gold. So gold has been taken, the mining dump has been dumped in the near to the gold mine area. So since they removed some material from the earth, there is a big vacuum, okay, or a cavity created due to this mining activity. Okay, this is actually closed mine. So there are two type of mine they do. One is the open mine, one is the closed mine. Open mine means they excavate from the surface continuously up to the level they have to excavate. So those who seen the coal, okay, so Neyveli power plant. So Neyveli power plant and other some of the coal mines are the open mine. People starting excavation from the surface and they remove the material, unwanted material, dump it on one place, and then wherever they found useful material like iron ore, coal ore. Okay, so iron ore is another open mine you can see in the Bellary region. So then that material they will extract. Those kind of mines are called as a open mine. So open mine generally destroy the forest and also change the landscape, and it also causes a landslide and other things and all. So in some extent it may also cause a tectonic imbalance in the region if the open mines are done for the very deep level of overburden has been removed. Okay, so for example, if they remove 500-meter overburden soil at particular place, nearby there is again against a 500-meter, then there is an imbalance between the overburden which causes a tectonical imbalance. So those are all the one type of mine. The another one is a closed mine. Closed mine means they make a hole. Okay, then they send a man and tunneling. Okay, like rat holes. They make a tunnel. In the tunnel, they go and excavate wherever they find a useful material. That kind of mining is as a closed mine. The KGF mine is a closed mine where they have the tunnel entry point. The tunnel goes and goes to the several places. So those people who have seen the what is that movie called actually? It is a very classical movie. Many of the kids will like. So where they say that if you can go inside the earth and there is a one more world below the earth surface. I am not getting that this one movie exactly. So where they show that mines, closed mines, how it is having a big space below the ground. So ground it may looks plain, you may not see anything, but once you enter to the mine tunnel, you can see a big area, okay, where people will be working or it will be empty and connected by a track. Okay, so kind of things. So the interior of the earth, okay, that movie I think interior of the earth. So that movie you can see that they show the closed mine inside how it is and all. So this KGF is actually closed mine where there is a big cavity below the ground. But ground people are still living by construction of the house and drilling up holes, lot of things, but there is a big cavity. So because of the removal of the material, the imbalance forces causes, that causes a earthquake, that is called as a collapsible earthquake. So which happens due to the small earthquakes in the underground caverns and mines that caused by a seismic wave produced explosion of the rocks on the surface and other activities kind of thing. So this collapsible earthquakes are very famous in KGF. People who are living in the KGF area, okay, so you can ask them, so they feel this kind of vibration very frequently. It will not cause any damage to house, but still the house will vibrate, vessels will fall, people will feel that vibration. So the another one is the explosion earthquake. Explosion is the man-made earthquake kind of things, like people will do terrorist activity or do explosion for the mining or some kind of this kind of the earthquakes are called as a explosion earthquake. Another is the impact earthquake. Impact earthquake is basically this is some kind of driving some thing, like people who are studied civil engineering, they know that there is a file driving, okay, cast in situ file. So driving the impact that file in the ground by hammering, that creates a impact vibration, that kind of earthquake is called as a impact earthquake. But you can note that all these four type of earthquakes only 5% in the world. Only tectonic earthquakes are the 95% of the world. Okay. So apart from this, there is also a reservoir triggered earthquake. So this happens in the reservoir area where due to the construction of the dam, huge amount of the water has been stored at a particular place, which causes again the imbalance force at below that location. If there is a chance, there is a weak zone, fracture, fault exists in those areas, because of filling up the reservoir and emptying up the reservoir, you will create a imbalance force that causes a seismic activity in that region, that is called as a reservoir triggered earthquake. So the Koina actually, where there is a weak zone, the dam has been constructed close to that. Whenever they fill a dam, there is a earthquakes are reporting. This is actually the number of earthquake, and then due to the filling level of the reservoir, you can see the graph which is very clearly explains the filling, the consequently causes a number of seismic events, you can see. So there was a one bigger event, so which is sometime happens the large imbalance of the force, which is reservoir triggered earthquake, that is called as a Koina earthquake. Many people died due to that earthquake, okay, in southern India. Okay, after that only this reservoir triggered earthquake concept has been developed. People try to understand before building the dam or existing dam how the reservoir triggering is happening at particular location, as the dam is safe for its own earthquake or people around is safe or not, they try to understand. So this is a reservoir. Then the type of earthquake based on the depth. Okay. So that depends upon the depth where it occurs. It can be divided as a three categories: shallow focus, intermediate focus and deep focus. Shallow is earthquake occurring less than 70 km. Deep is earthquake occurring more than 300 km. So in between 70 to 300 is intermediate focus. About 90% of the earthquake in the world is actually occurring less than 100 km. Okay, so the shallow focus energy will reach very surface very fast when compared to deep focus earthquake. So the another earthquake is depends upon the where the earthquakes is occurring. So interplate, intraplate and midplate. So what is the interplate, intraplate? If you take the Indian plate hitting with the Eurasian plate, so there is a joints in between this plate boundaries. So wherever the earthquakes are occurring in between joint of the plate, that is called as a interplate earthquake. Okay, the interplate earthquake basically due to the plate joints, so the movement and then subduction whatever is taking place, diversion whatever taking place, that is responsible for the inter. So there are some earthquakes which you can quote for the interplate earthquake: Kashmir earthquake, Assam earthquake, okay, Chomali earthquake, Bihar Nepal earthquake, Uttarakhandi earthquakes are the example for the this kind of interplate earthquake. So the earthquakes occurring, okay, so interior of the tectonic plate away from the interplate region, that kind of earthquakes are called as a intraplate earthquake. So this generally occurs in the away from the plate boundary. So these earthquakes also very violent and vibrant, but the magnitude of interplate will be you can expect up to starting from 9.7, 10, 8, those kind of higher magnitude. The intraplate earthquakes are moderate in size, or mega earthquake up to 7, 8. The highest magnitude was reported close to 7.5 or 6, something like that. So up to 8 magnitude you can expect, but this also causes a huge amount of the damage. So many intraplate earthquake can be quoted for India, because in the recent about 40-50 decade, we are 4-5 decade, not 45, 40-50 years or 4-5 decade. So we actually had several intraplate earthquakes like the Bhuj earthquake, okay, so then the Jabalpur earthquake, Kilari earthquake, Koina earthquake. These are all happened in the intraplate region of the Indian plate. So this earthquake actually alerted the international community that even a intraplate can release a earthquake and kill several people. Okay, so then the mid plate is the earthquake which occurring middle of the plate, which is like 1000 km away from the plate boundaries. So the intraplate earthquake is actually after few kilometer away from the plate boundary. Okay, this is 1000 km away from, this is called as a mid plate earthquakes. So we have to depends upon the where the earthquake occurring, you can see that the change in the size, change in the wave propagation, change in the energy content. Okay, so after 10 km of the plate boundary, whatever earthquakes are occurring is called as intraplate earthquake. So after 1000 km of the plate boundary, whatever earthquake is called as a mid plate earthquake. So within 10 km, whatever earthquakes are occurring in the plate boundary is called as a interplate earthquake. So this is how you can see the classification of the earthquake. So this will help you basically to identify what type of region you live, what type of earthquake you can expect in that region, like tectonic earthquake, shallow focus earthquake, interplate or intraplate earthquake. As you are seeing that the wave propagation of these earthquakes are completely different. Okay, so understanding of this will help you to predict hazard due to this kind of earthquakes. Okay, so with this we finish a recap class 3, where we discussed a fault type, source type and the earthquake type, and try to understand, classify the earthquake depends upon the depth and the location and then the size kind of things. Okay, so that is why we are done. So thank you very much for watching this video. So we will meet you in the next class. Okay, thank you.